Today we're going to be talking about how to graph ordered pairs or points on a coordinate plane. Today's number routine is called alike and different. Write down 2 ways these numbers are alike and 2 ways these numbers are different. Be ready to share when time is up. Oh, 0 seconds, so time is up. So why are they different? Well, the negative sign is inside the absolute value bar and the negative sign on the outside. They're different because they both have different value. What's the absolute value? How far is negative 15 from 0? The absolute value of negative 15 is 15. How far is 50? So let me get my pen for that one. Let's use, I like this one. So it's 15. How far is 15 from 0? 15 units. But what's the opposite of 15? Negative 15. So they both have different value. How are they alike? They both are 15. They both have the number 15. They both have negative sign. They're both absolute value. Many ways you can say it. So the absolute value of negative 15 is 15. The opposite of the absolute value of 15 is negative 15. So in our warm-up for today, order these integers from least to greatest. So let's start with the first one. If I had a number line, how far is 5 from 0? 5 units. So the answer is 5? Nope. Opposite of 5 is negative 5. What's 72? How many 8s go into 72? Or this means a divide. This is an improper fraction. How many 8s go into 72? 9 units. So 9. How many 8s go into 72? 9. So 72 divided 8 is 9. Negative 3 is negative 3. That's an integer. 8 is an integer. Again, what is an integer? A positive or negative whole number that includes 0. How far is 3 from 0? 3 units. What's 48 divided by 6? Or how many 6s go into 48? 8 times. So that's negative 8. How far is negative 8 from 0? 8 units. And negative 7. Put them from least to greatest. If you want, it's your own preference. You can draw a number line. Here is 0. I know positives are on the right, negatives are on the left. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is negative 1, negative 2. As you see, I'm getting smaller. I'm getting away from 0. Negative 3, negative 4, negative 5, negative 6, and negative 7. Let me use a highlighter. Negative 5 is right here. 9 is right here. Negative 3 is right here. 8 is here. 3 is here. 8 is here again. And negative 7 is here. So which one is the least? Remember, in the number line, it goes from least to greatest. So the least is negative 7, negative 5, negative 3, 3, 8, 8, and 9. Negative 7 is the least integer here, while 9 is the greatest integer. Video time. As soon as I selected video time.
Man, this place looks expensive. I feel like I'm wasting a fortune just standing here.
So the question for today is, where is Homer located at? Tell me what you know about that signpost. Let's go back to the signpost. What is signpost? What do you know about this signpost? I see X, Y, and Z. Well, we don't really talk about Z. You'll talk about Z in the 3rd dimension when you go to calculus or pre-calculus in the 11th, 12th grade or college. But we should have recognized X-axis and Y-axis. Do you remember anything about coordinate planes? Well, we have X-axis is a number line that is horizontal, that is called X-axis, And a number line that is vertical is called y-axis. And when they intersect, when these two number lines form a right angle, they intersect. This is called the origin. And it is, remember, at 0, 0. Because this is a number line, we know positives goes to the right of 0 and negatives go to the left of 0. In a vertical number line, positives go up, negatives go down. What is the purpose of what is the purpose of coordinate plane? It's a lot in the military they do use it, and planes they use it for location purposes. Sometimes you see the equator. You ever see the coordinates like they use degrees? So in this one, so you have the x-axis, you have the y-axis. These are two number lines that intersect and form 4 right angles. All right, so let me use my select button. This is the origin. 0, 0 is the home base. Let me highlight it so we know this is the home base. As you can tell, this coordinate plane is divided into 4 quadrants, or 4 quarters, or 4 sections, or 4 groups. This is quadrant. This is quadrant 1. This is quadrant 2. This is quadrant 3, and this is quadrant 4. I'll be honest, I myself have a hard time memorizing which quadrant goes to which one. It is very important that you do understand which quadrant goes to which. Quadrant 1. The way I memorize it is, let me use my highlighter. Think of the word coordinate, C. To make a C for coordinate, I start at quadrant 1, then I go to quadrant 2, then I go to quadrant 3, then I go to quadrant 4. That's how I memorize it. There are many ways you can memorize it, but quadrant 1 has all the positive numbers. Oh, I forgot. Wait, let me go back. I forgot to label the x-axis. This is the x-axis, which is the number line. This is the y-axis, which is another number line. So as you can tell, it's divided into 4 quadrants: quadrant 1, quadrant 2, quadrant 3, quadrant 4. So what type of numbers go into quadrant 1? Positive numbers. So how do you graph a coordinate? For example, if I had an order pair right here, order pair is another word for point. What is this location? So starting at the origin, I look at the x-axis. On the x-axis, it's located at 5, comma. On the y-axis, it's located at 2. So the order pair is 5, 2. So as you can tell, quadrant 1 is nothing but positives and positives. Let's use a different pen color. Quadrant 2, let's find the location of this point right here. Starting at 0, what is the location of this red order pair for x-axis? It's -6. On the y-axis, it would be 3. So make sure you put the parentheses, -6, 3. So what can you tell me about numbers, order pairs in quadrant 2? It's always going to be negative, then positive. In quadrant 3, let's look at this one right here. So starting at 0, I go over -5 on the x-axis, and the y-axis is -5. So it's -5, -5. What can you tell me about numbers in order pairs in quadrant 3? They're both going to be negative, negative. And last but not least, we have quadrant 4. Let's use this one. So in the x-axis, it would be 3. On the y-axis, it would be -5. So what can you tell me about order pairs in quadrant 4? It's always going to be positive, then negative. kids have a good time with that one, are okay with that one. This is where kids mess up. What happens if you have a point that is located right here, right exactly here? Which quadrant would that be on? So first of all, let's find the location of this ordered pair. I start on the x-axis is just 0, so I'm not moving anywhere. On the y-axis is -2. So is this in a quadrant? No, it is. It's located on the y-axis. It's located on the y number line. So 0, -2. Let's graph this one. Can you tell me the location of this ordered pair? Starting on the x-axis is located, starting at 0, it goes over -5. On the y-axis, do I go up or down? Do I move anywhere? No, 0. So is this in a quadrant? Nope, it's not in quadrant 2 or not in quadrant 3. This is quadrant 2 has to be negative, positive. Quadrant 3 has to be negative, negative. So this is just located on the x-axis. So again, a coordinate plane is divided into 4 quadrants, the way I memorize it, but C for coordinate, quadrant 1, quadrant 2, quadrant 3, quadrant 4. In quadrant 1, we have nothing but positives. In quadrant 2, we go negative and then up, so it's negative, positive. Quadrant 3 is negative, negative. You go negative, left, down, negative. And quadrant 4 is positive and negative. X-axis is always horizontal. Y-axis is always vertical. To graph a point, for example, this one, you look at the, start at 0, you look at the x-axis. And the x-axis is -3. The y-axis 2. So ordered pairs are always x, comma, y. X comes before y. Think of the alphabet. If you always get mistakes, like, which one do I look at first? X comes before y, because I have kids who make a mistake on the test and do y, comma, x. X, comma, y. So if I had a quick quiz on this one, could you figure out which one goes to which? Let's see, C for coordinate. So quadrant 1, quadrant 2, quadrant 3, quadrant 4, or just a home base. Let's see, if I go over and up, positive, positive. If I go back left of 0, it's negative, up. So it's negative, positive. I go left of 0, negative, below, negative. And so quadrant 4 is positive, negative. And I think that is, oh, let's try one more harder one. Nope. I want to try this one. So if I asked you to graph this one, where would it be? Starting at 0, -184. That'd be left of 0. 292, that's be above 0. So it'll be quadrant 2. I don't know why. Slide a smiley face to the quadrant where it would lie. Graph it using a red dot. So it'll be somewhere here. Next one. Positive, so it'll be right of 0. Negative means below. So it must be in quadrant 4. So right of 0, below. Next one. Where would you find this one? Left of 0, above. So that would be quadrant 2. Ooh, positive, positive. Where would you find positive, positive? Quadrant 1. Right of 0, above 0. And last but not least, negative, negative. Left of 0, below 0. So it'll be right somewhere here. So it'll be quadrant 3. So this is the study of coordinates. So a coordinate is divided in quadrant 1, quadrant 2, quadrant 3, quadrant 4. The home base is called origin. And you always graph x, then y.